Amen.
Okay, is the sound all right?
Sound is
Yes.
good.
Awesome. Oh, great. Okay, it's 3:05. I'm Panagiotis Moustafellos. I'm a site reliability engineer at Elastic, and my team is responsible for the high availability, fault tolerance, and performance of Elastic Cloud, which is Elastic's offering of managed Elasticsearch clusters and Kibana instances. Elastic Cloud is currently deployed around the world in 8 geographical regions on AWS, and will be expanding on other public cloud providers very soon. We also have a new product that we call Elastic Cloud Enterprise, which is basically our SaaS bundled in a way that can be installed on premises, even on air-gapped environments for customers that are very sensitive about security or are in a very regulated, highly regulated realm. So, the topic of this talk is about monitoring. The venue has already had some speakers that discussed microservices, and monitoring is an integral part of this new era of microservices. All right. The original talk was created and submitted by my colleague Philip Kren. He's an infrastructure engineer at Elastic and also a developer advocate, so kudos to him. So, some facts first. This funny quote is actually very real in many situations, and it's very true that when you're dealing with microservices, you get some benefits right out of the bat, but you also get introduced to another level of complexity. Whereas a monolith is kind of easier to debug, and you have your logs in one place perhaps, and you have a singular way of deploying. That's not always desired in the terms of speed of deployment and production of mission critical or very focused microservices. Right. Okay, so this is the situation that most development teams are in right now when they are switching from a monolithic approach to a microservices approach. You sit around in your office and you have your team meetings and you believe that everything is fine, where actually they might as well be very wrong, but you wouldn't know until you are facing an outage, right? Could I have a raise of hands? Who here are titled developers or software engineers or something like that? Okay, pretty much everyone. Systems engineers? Okay, so yeah, I'm a systems guy too, and we are very underrepresented in such conferences, right? Because the focus is mainly for developers. So you know that your development team is quite likely unaware of the dangers that get introduced in a system that its complexity rises when more moving parts are being deployed. Like developers love microservices, systems guys too, like there is no doubt about it, because microservices introduce the Unix paradigm in the world of software engineering and development. So you develop a tool or an API or a service or something that has a very bounded context, does only a few things, and it does it right. Okay, but you also get some benefits like partial deployment and whatnot. But all those moving parts introduce a whole new level and domain of failure that was otherwise unknown for most development teams. Right? You are introduced in the concept of cascading failures, of thundering herd issues. Like, could I have another raise of hands? Who is using a microservices approach right now in production? Okay, quite a few, right? How confident are you, like if I told you right now what will happen if service X goes down, would you know what will happen in production? Have you tested it? Nobody? Okay, just one brave hand. All right, cool. So you are in this situation. This is fine for you. Okay. And when an outage strikes, sorry, this is where you are at. Okay, this is a very standard situation for most systems guys, SREs, operators, DevOps people. Something goes wrong, and then you just realize that, hey, this is not fine. Actually, my system is in a whole new world of pain, and I don't know what to do about it, right? So, that's a very nice quote by Sam Newman. He's the one that wrote this nice book about building microservices. I highly recommend this book. So if you want to implement microservices, says Sam Newman, the first thing you need to do is implement aggregated logging. The second thing is implementing correlation IDs. And this is very true, and we'll see why in the next slides. Okay. So do you really monitor your system and services right now? Do you use perhaps an APM, or do you have something like a centralized aggregating logging infrastructure in place? Raise of hands. Okay, cool. Any of you using Elasticstack? Oh, that's nice. Cool. Okay. Okay, the goal would be to monitor all the things, right? And not only monitoring the services per se, but also monitoring high-level things, like your KPIs. And KPIs in systems can be very different from what the business KPIs are, right? Perhaps in the business model, you are interested in how many signups you have in your service per day, or how many cluster creations, or how many sales you achieve in your e-commerce platform. Whereas in the systems, we'll care about latency, I don't know, hot threads, or swapping or whatnot. But in the end, the high-level monitoring is very beneficial to systems people as well, because when you have a very distributed, organized way of deploying your services, it's very hard to tell what the impact of a failure is, right? You could have what seemingly is a minimal failure affecting something crucial for your business model. Like, it's very beneficial for you to also monitor signups per se, and if you see that for an hour you don't have any sign up, then you know that something is very wrong, right? You don't have to wait for your login service to indicate a massive failure to understand that something's going wrong. But this is not the scope of the talk. It's just a word of advice that as we mature in this microservices approach, all teams tend to converge in the logging goal, right? You could very easily have business people using your logging infrastructure to get an idea of what's going on in terms of their KPIs, and in return you get the extra benefit that you have some alerts, and and you can act proactively or reactively in situations of failure. For example, some colleagues of mine at Netflix, they have some KPIs like and alarms based on how many plays you get per minute, like how many people click and actually stream a video. And when this number drops, they know that something is wrong. If it's not affected by seasonality or something else, then something is very, very wrong, and they have to investigate. They don't only wait for a single microservice to produce some errors, and then that will trigger an investigation. Okay. So how do you log and monitor? I have a short demo. I created a small application using Spring Boot. I'm not a Java person, so this is the easiest thing that I could do. This generates a nice skeleton to bootstrap a microservice. It gets you a project ready to be built with Gradle, and you get your dependencies in a nice tree, and then you build your jars and you deploy them. Okay. For this demo, I'm using Amazon Lightsail, but you can very easily use any provider that gives you access to some VMs that spawn almost instantaneously. I'm using Terraform to deploy, to provision my infrastructure, and Ansible to actually configure the VMs. but the demo could very easily hold on to any other provider. I'm also using Elastic Cloud to spin up Elasticsearch and Kibana, and this is where we will ingest our data and how we're going to visualize them in Kibana. So for those that are not familiar with the Elastic stack, I'll go bottom up. Okay, Kibana is our visualization tool that sits on top of Elasticsearch. It uses Elasticsearch as a backend, and it produces this nice visualization and graphs that we see in the next steps. Elasticsearch is our data store, our search engine, which is it's used very heavily in the logging scenario as well, not just as a search engine or as a recommendation engine. We won't be seeing Logstas in this demo, but Logstas is basically the medium between some either queues or some log shippers that accept the logs, transform them, and then stuff them in Elasticsearch. Bits, that's a relatively new product for Elastic, and they're basically lightweight shippers that ship log or other type of metrics from your infrastructure. There's also XPack that is not mentioned here. It's our commercial offering that adds some extra capabilities in the Elastic stack. Okay, let's see some demo now. Okay. Oops. All right. Okay. As I told you, I'm using Terraform to provision my environment here. And what Terraform is basically is a tool that is provider agnostic, has multiple providers that it can plug into, and has a very nice. Yeah, sure. Yeah. I think I can at least. Okay. Better? Okay. Terraform is a very nice tool. I believe it's the leader in infrastructure as code. It has this very elegant way of defining resources with a language called HCL. And you can define your resources, and then it compares the desired state that you have defined in your code with that of your targeted provider, in our case AWS. So in this case, it will provision some light sail instances. It will add a Route 53 domain for our DNS, and will also add some SSH keys, as well as, in the end, associate some DNS records to the instances that we are going to create, right? And since the upstream in this venue is a bit flaky, I have already provisioned the machines for us. So we're not going to be seeing that bit. And when the instances are up, I'm using Ansible to deploy, to configure and deploy our backend service. Well, pretty much, I think that Ansible is a very nice way to provision VMs, and it's very developer friendly. It has this nice little YAML syntax that pretty much, if you use Ansible, it's very easy to pass this towards your development team to also contribute. It's not just for systems people. Okay, let's see. So for this demo, I have inserted some dashboards. These are found in our bits repo, and you can very easily create them your own. So I have provisioned 2 VMs, and I have created, I have shipped what we call metric bit, which is a data shipper So with the help of metric bit, which is a very lightweight polar of info for our system that targets our Elasticsearch instance and ships the data in there, we can see a very nice overview of what our system is currently doing. I will enable some auto refresh for Kibana, so we have some real-time indication of what's up in our system, right? And you can see here a list of processes and their CPU usage, as well as the memory usage per process for our two VMs. I will log into my instance now, and I will try to demo what memory leak would look like and how we will view it in Kibana. So I will run this little jar. I will assign a small heap size. Okay, it's running. And we should be seeing a spike here in the memory usage per process, if all goes as to plan and if demo goods are nice to me. Okay, so we start to see a spike in the memory usage of a process. We can drill down and see that it's Java that's causing this, this spike, which is very Java-like, I guess. Since it's refreshing, we don't have a specific ordering of hosts, but you can see that, okay, it can pop up to one another. And my application is very carefully designed to consume all memory allocated for it and then fail, which again is very Java-like. And okay, we have our error. Okay. So an operator here can very easily distinguish and see this anomaly, and then he can drill down, he can focus in exactly the time frame that the error was occurring and realize like that something is wrong here, so I have to do something about it, and drill down into the Java process and get some more information. We're not going to do that right now because we're going to see something else that's perhaps even cooler. So since this is dead, I'll run some services. So I'll run Zipkin, which is a nice profiler for Java, and specifically has a nice integration with my Bootspring application. In case you were wondering what my application was doing before it crashed, it was basically this little thing, right? We just consume all memory, all heap, and then would die. I just wanted to see the anomaly in my Kibana dashboard. Okay, so Zipkin is running. I will also launch my frontend application so we can play with it. Okay, it's booting up. Takes a few seconds. Again, this is Java. Some people like it. Okay. Awesome. So we have this very nice little service running, and you can access it by going to pmoust.wtf. Pmoust is my Twitter handle. And you are presented with a nice little error page here because there is nothing there for this application, but you can also check the /good endpoint, and you get 200. If you do have Wi-Fi, please do that, because you're going to see the results in Kibana in a little while. You could, if you want to, you could hit that endpoint right now in order to make this demo a bit more, interactive. And of course, since there is a /good endpoint, there's also a bad right? Okay, and this is 500. Okay, let's see what we have here in our dashboards. So I have this application running right now, and I want to see exactly what's happening on the HTTP layer for my infrastructure, right? I'll check packet bit, which is another bit. Let's see, generic dashboard. Packet bit is awesome. I really like packet bit a lot. What it does, it sits on like not on top, but side by side with your network stack. And assume that your device is in promiscuous mode, it will be able to deduct what calls exactly are happening to your specific system, and will then ship them to Elasticsearch. Since here we don't have any DB transactions or cache transactions, but we do have web, we're going to check the web transactions and see what you guys have been doing. Again, this comes out of the box. It doesn't need any type of configuration apart from defining your outputs to be in Elasticsearch, in your Elasticsearch cluster. But other than that, you don't need to configure packet bit for your HTTP server, let's say, or your application server. Packet bit will be able to detect what's going on by filtering the packets and making some sense out of them. So we have some requests here. Oh, you've been very chatty. Okay. Okay. So I can see now what exactly is going on with my service. And well, you're very kind. Normally, when I give this presentation, or when Philip does, people just do slash something, and it's mostly naughty. It's like your presentation sucks, or you're fat, or something. But you've been especially good, so thanks for that. Okay, and we have this, again, these dashboards come out of the box. You can make your own. This is just for demo purposes. But there's a very handy Python tool that helps you import them into your Kibana dashboards, and it's very easy to get things started. Awesome, of course. It's awesome. Cool. So we saw that we created some errors later on, earlier on. Let's see the flow here. Okay. So this is again a real-time visualization of what's going on in terms of connections in the system. This is not actual the connection that you make over the HTTP server, but it's also the connection that's happening within the system. Like we have this application, but we also have an Nginx frontend to act as a reverse proxy. So this way you see this to be like multiplied. So if I was to, let's see, run, okay, Apache benchmark here. Let's not kill my, okay, you should be familiar with Apache benchmark if you are a web developer. It's basically a tool by the Apache Foundation that helps you benchmark your service by adding, at least these are the most basic flags, the number of requests and the number of the concurrency level, I guess. So, okay, let's hit it. Oh, that was fast. We should be seeing a spike here. Hopefully. Yeah, and we see it rising. Let's increase that count. Okay. So yeah, the spike is evident right now. And you can see that the counts also for, the source IP is the same. But for the web transaction, since I'm hitting the good endpoint, you can see that they're very heavily increased. Do you prefer Golang over Java? Of course, there's no question about that. Sorry. Okay. Let's see, what else? We saw metric bit, we saw packet bit. Oh, there's another very nice tool that I think that you like a lot. Heartbeat. Okay. Okay. So what Heartbeat does this is actually, it's a funny story about Heartbeat. Heartbeat was developed by the Beats team after my team requested it as a feature, right? We had this problem. At Elastic Cloud, we deploy several tens of thousands of clusters, right? And we wanted to provide an SLA agreement with our customers, and we wanted to find perhaps a SaaS that would accept the volume of the data that we wanted to ship to them, right? And we wanted to have granular control over the, let's say, over the time frame that we define as the service being up. So now we have an SLA agreement with our customers that indicates that if after, I don't know, 3 nights and a half of downtime within a given month, you can very easily, request your money back or something like that. We did some market research and figured out that the pricing was insane for the amount of data that we wanted to provide, and there was nothing there for us. So we requested the Beats team to step up and create this very nifty little monitoring tool that basically what it does, you define a set of monitors. In our case, I'm monitoring the /good endpoint, right? And we get an indication of whether if it's up or down. Since I just started my application, it was registered here as a downtime until I fired up my Java application. Right. So this is very handy if you have a microservices approach and you have multiple tons of endpoints, or you have some API endpoints that are expected to produce a specific output, then you can very easily define in a nice little YAML in your Heartbeat monitor all those patterns that you want to monitor for. For example, in the case of Elastic Cloud, we have tens of thousands of monitors because we monitor each and every individual cluster. And yeah, it's more impressive than what you see here, of course. Okay, let's induce some downtime so we can, okay, let's kill it. Okay. So supposedly, Heartbeat should catch that, and yeah, okay. So there's a problem here, and this would supposedly trigger some alerts for you. It's very nifty because it also has the duration heat map, so you can not only trigger alarms for total outage, but for server degradation, like having a very high latency. Let's bring the service up now. Cool. Again, it's something that you most likely do already, like services like Pingdom or, I don't know, other services like that do it commercially, but what happens if you have, I don't know, 300 microservices that have specific API endpoints that give you a health check indication? Then it gets really pricey, and it's not very easy to define your monitors as code. Whereas with Heartbeat, it's very easy to have it committed in a Git repo and have it deployed in your scheduler or something, and have your own monitoring service right off the bat. Okay. Let's see what else. Oh, there's also, of course, FileBeat. Which again, I'm running on the VM that powers my application, and I can see the engineer's access over time. It has a nice little graph, and yeah, we're in Greece, so yeah, of course. But we also, I'm running Heartbeat from the US, so I should be seeing, yeah, I'm seeing here some pings from the US, and this is my monitoring service. This is where Heartbeat runs, and this is why it's logged over here. And you can very easily correlate this spike. This is most likely the time that I run Apache Benchmark. And again, this is something that you can very easily deploy in just a few minutes. It's pretty nice. What else is there? Let's cover some stuff. Okay. So apart from visualization, you can also drill down to events and Elasticsearch search engine, right? So you can do a free-from text here, text search here, and drill down to some errors. So we visited the /bad endpoint, and we got some errors. So let's see what about them. So when I'm searching bad in this field for my file bit index, I can check what exactly went wrong, and I can see a part of my stack trace, which again is very useful. And this is the error, my bad, something went wrong. We saw that earlier with, let's see. Okay, my bad, something went wrong. So you can query about that and fetch the errors. Okay, so this is nice. But then again, this is just basic stuff, right? Some people might have them solved, some others really don't. At my previous company, People Per Hour, it's a Greek it's a startup from the UK, but has its IT offices in Greece. We had developed a nice little pattern where we, each microservice that we would ship, we have back then a logstats forwarder profile, right? That would define within the repo where a logstats forwarder shipper would find the logs and what type of logs they would be, how to tag them, and how to ship them to Elasticsearch. So each time that we deployed a new application version, it would be tagged, and it would be under the developer's control which files to be included as a log stream into Elasticsearch, which was great. Some developers used that heavily, and that it was awesome. Others completely ignored it. Some of those are in the audience, and this is kudos to them. All right, let's move on. Okay, that's a small, like a war story from my startup days before joining Elastic. So we used to have a little bug that would be very annoying for us. We'd use New Relic back then, and we'd log some exceptions, right? And we have these exceptions, some weird exception coming on. Let me present that. Okay. So this is Kibana 4. It's not the latest, because it's years back. So we have this exception coming on where, for example, that's about money, right? That's important. We couldn't raise a refund because the money could not be, the actual transaction of the financial transaction was not found into our tables. But this could not happen because in order for this event to be fired, there has to be a transaction in place, right? So we'd keep getting this error, and we couldn't debug it because in Relic it was very messy. At some point, we felt it was coming too often. And since we had deployed Elasticsearch and Kibana, we decided to graph this, right? And we came up with this graph. Actually, I wasn't involved at that time. It was just two developers. And as I was sitting at in my desk, minding my shift, a developer comes close to me and says, Panos, listen, we have a very severe issue. I say, okay, what's the issue? Replication lag. Our slaves in RDS, our MySQL slaves, are lagging. I was like, whoa, okay, that sounds scary. Why do you assume so? Because, dude, we have these exceptions, and they happen every time there is traffic. Now, check the week pattern. Like there's the weeks and the weekends. Each time there is traffic, and presumably there is replication lag, we get these hidden transactions. We see them in the tables. If I do a select, I can see the transactions, but my asynchronous service that consumes those events does not see them. Like, okay, that sounds scary. Let's see what's up. So we did investigate RDS and saw that there was no replication lag. Okay, that's weird. So it must be your code. That's my, and this is why, what the point I'm trying to make here, we eventually debugged it. It was an issue about transaction isolation levels in MySQL. So it was a software bug in the end. It wasn't infrastructure bug. But without proper monitoring, right, just using, throwing in some APMs like whatever you might use right now, and if you don't correlate your system's health with your application logging, then you can't really see the bigger picture, right? So you have a senior developer approaching you, and he has his hypothesis, and he's sure because he has unit tests, and his unit tests prove that he can't be wrong. He has tested this exact scenario, right? So it must be you. It must be the systems guy that has the fault, right? As soon as we graphed this in Kibana, and when we graphed the replication lag in Kibana as well, we correlated that, and it made no sense. And this is where we knew that we had to dig further down into our application code base and figure out the bug. So what's the takeaway from that? Is that there are two fallacies that it's very easy to get trapped into. One, because if you're in a development team, you know that your code is shit, right? You know that. You know that the monstrosity that you have developed, most likely. Everyone has some bad stuff hidden in their code. So you automatically assume that, yeah, it's me. I fucked up. My code is terrible, so I must be at fault, right? Or or the exact opposite fallacy, which is, I know my code, it's perfect. I have a ton of unit tests and integration tests. I can't be wrong. It's you. It's something else. So those situations are both bad. Okay, you don't want to trap yourself into these fallacies, and the only way to escape from these fallacies is to resort back into the scientific method. What's the scientific method? Like you examine the environment, you examine the phenomena, and then you try to make sense out of them. So you try some hypotheses, right? And then you have to deduct or extract some information that will be valuable, and then you can come into a conclusion, right? This is a basic scientific method. And the only way to do that is actually to have visibility on top of all your metrics. Okay? This is something that we don't do. Like, I've seen teams that have awesome infrastructure metrics, and they monitor everything, but they don't do aggregated log analysis, right? They don't correlate their application logs with their systems logs, metrics. So what's the good of it? Or the exact opposite, which might be even worse. You have all these logs, and you can see your exceptions and whatnot, but you can't correlate them to some other events that might be more systemic. So the takeaway, I guess, what I'm trying to say is, sorry about that. We've seen all that. The takeaway is that if you are going to move into a microservices paradigm, you have to have your logging scenario figured out. And using the Elastic Stack is a very nice way of doing that very easily, and there's a whole community that can help you. The documentation is great, so please try that out. Okay, isometry bit, packet bit, file bit, hard bit. Okay, Zipkin. We don't have much time for Zipkin, but just let me see what I can do real fast. Okay, so Zipkin. Okay. Zipkin can help you trace your application's calls, so you can very easily see, you see in Kibana that there is a peak in either latency or error rates or something, and then you want to profile your actual application. Zipkin helps you do that, and it has a very nice integration with Spring, and it's a nice way to get these features that you can see in some fancy APM offerings, right? Okay, so let me call /call. It actually does the calls, and I'll search for it. Call. Oh, no, sorry. Okay. Okay, cool. Okay. So what Zipkin does, it inserts a transaction ID into any given transaction in your application, and then you can profile the actual flow of the events within your application. So you can see when the client requested something and then what came along. In our case, it's just two little calls. The parent call then calls /home, and then you can see the drill down. It's not impressive right now, but if you had a very complex application, you would give a very nice drill down of what's going on in your app, and then you can profile which function or which class or whatever is the one to blame for latency or whatnot. Okay. I'm running a bit out of time, so. Okay. There's also more. Okay, what I would love to have for this demo, like I was asked to get this demo. Okay. Right, I will conclude in just a couple minutes. Okay, I would love to have Kibana annotation. What are Kibana annotations? There is an open ticket about it, and there's an open pull request, and it's being reviewed. It's like when you deploy a specific, I don't know, patch or a specific microservice, it would be great to have in your Kibana timeline the exact time that this happened. This is something that's not there yet, but it will be there soon. Perhaps greater support for nested aggregation, so you can get some sense out of heavily complex data structures that could be perhaps transactions ID or span IDs that could be interlinked within microservices, and then you can get a whole overview, a chain of events within Kibana. A nice to have would be Elasticsearch rollups. It would make sense to keep data, locking data for years, right? But it's too expensive to do so. So you might want to have sub-second granularity for a day's data, but you don't want to do that for like 5 months back. So it would be great to Elasticsearch to have some more elegant rollups, but that's also coming soon. We will be exposing a public API for Elastic Cloud, so you can have a Terraform provider, so you can provision your Elasticsearch clusters with greater ease. And I would love to see APM as a first-class citizen in the Elastic Stack. And what I would really love to see would be a Kibana Flame Graph plugin. We don't have time to explain what a flame graph is exactly, but for those systems guys or girls that have been involved with performance analysis, definitely check Brendan Gregg's blog post about Java in Flames. It's a great topic. But those are coming soon. We've also released a beta version of what we call Elasticsearch machine learning in XPack for 5.4, which was released a few weeks back. This will be something very disruptive. You can make sense, you can see spikes and you can understand stuff out of spikes, but it's not, you cannot deduct information or significant importance from just a graph. Machine learning can help you understand what are the anomalies in your data, and something great to have, and you can play around with it right now. You can download Elasticsearch and has XPack in, and just check out machine learning module. It's great. Conclusion. Have an all-around visibility in your distributed system. Don't just care about system metrics or just for application logs. Have them somewhere aggregated where you can correlate data and then reach into conclusions. And that's it. Thanks a lot.
All righty, we do have a little bit of time. Any questions for Panagiotis? Maybe a few points you'd like to discuss, or maybe some advice or anything like that?
You mentioned lots of times in your presentation the correlation.
Yeah.
Was that the timestamps? Because if we're talking about multiple systems, multiple applications, how else do you correlate apart from timestamps and correlation IDs?
Mm-hmm. Okay, one way would be to have specific transaction IDs, right? And you can tag, I can imagine with HTTP services, if you have a header that's accompanying, if you have a request that spans across your microservices and can be traced back to a specific parent request, that will make sense. You can make sense of some trail of events. In the case of the demo here, the Kibana demo, it's just timestamps that you can correlate. You can have your visualizations, one on top of the other, drill down in the specific time frame and deduct what's going on. It's especially, I know what you're saying, if you have different indexes, it's very hard to correlate stuff, right? But it's coming soon, something much more better and much more granular, but for now, timestamp is good for the grand majority of the cases.
Thank you.
Question in the back over there. Let me just rush across.
Hello, thank you for this excellent talk. I have a question. It might be related to the previous one.
Could you speak up?
Yeah, it might be related to the previous one. You have showed us, for example, metric beat and heartbeat. Yeah. The information from those shippers are stored in different indices, aren't they?
Yeah.
Yeah. Is there any way to correlate those information, for example, when we see a spike in the memory, to correlate with this Java out-of-memory exception? Currently,
yeah, it's linked to the previous question, actually. You could have you could stuff them in the same index if you wanted to, or the same index pattern, so you can make better sense of drilling down Kibana based on tags, perhaps, or something like that. Right now, you're right, timestamp is king for those type of metrics that come from different places. So yeah, there is no, to my knowledge, a great way to actually aggregate all those without some extra plumbing.
One final question, perhaps? Yes, another one. Good.
Can we test this XPack without paid subscription, like you said previously for the machine learning pack?
What was the question again?
I thought that the XPack is in the paid subscription of Elastic Pack.
Yeah. You can,
is there a demo version? Or
yeah, there's a developer license that it's free for some time, so you can definitely toy around with it.
Okay, thank you very much.
Is there any other question?
Any other questions? Nope.
I will be in the lobby later on, and I also have some stickers with me if you want. So just, yeah, come say hi in the lobby. I'll be happy to answer more questions in more detail.
Panagiotis, thank you very much. Thank you. Fantastic. Okay, guys.